Have you ever wondered how an artificial intelligence system knows it has correctly identified an object in an image, or how it judges the precision of its own predictions? It is a fundamental question in computer vision, especially when dealing with bounding boxes around detected items. This critical assessment is often achieved through a metric called intersection over union, or IoU. Intersection over union provides a clear and intuitive measure of how much overlap exists between two bounding boxes, usually a predicted box and a ground truth box. Its immediate importance lies in its ability to quantify the accuracy of object localization, telling us if the artificial intelligence model has drawn its box in the right place. At its core, intersection over union works by comparing two areas. Imagine you have two rectangles, one that the artificial intelligence model predicted and one that represents the true location of the object. The intersection is the area where these two rectangles overlap. The union is the total area covered by both rectangles combined, including their overlap and their non-overlapping parts. The IoU value is then simply the ratio of the intersection area to the union area. This normalized ratio provides a score between 0 and 1, where 0 means no overlap at all and 1 means perfect overlap. This elegant mathematical relationship allows for a robust and scale-invariant evaluation, meaning it works regardless of the size of the objects being detected. To practically calculate IoU, you first need the coordinates of the two bounding boxes. Each box is typically defined by its top left corner and its bottom right corner. From these coordinates, you can determine the width and height of each box and then calculate its area. Next, you determine the coordinates of the intersection rectangle. This involves finding the maximum of the top left x coordinates, the maximum of the top left y coordinates, the minimum of the bottom right x coordinates, and the minimum of the bottom right y coordinates. If there is no overlap, the intersection area is 0. Once you have the intersection area and the individual areas of both boxes, you apply the formula. Intersection over union equals the intersection area divided by the sum of the area of box 1 plus the area of box 2 minus the intersection area. This is a common formula that prevents double counting the overlapping region. This metric is then used to filter out redundant detections or to determine if a detection is good enough, often against a predefined threshold like 0.5 or 0.75. Beyond simply evaluating individual detections, intersection over union plays a pivotal role in advanced computer vision techniques. For example, it is fundamental to the non-maximum suppression algorithm. Non-maximum suppression uses IoU to eliminate multiple overlapping bounding boxes that might have been predicted for the same object, ensuring that only the most confident and best localized detection is kept. It also helps differentiate between distinct objects that are close together, ensuring that each object gets its own unique and accurate bounding box. Understanding IoU is therefore not just about evaluating accuracy, but also about understanding how models refine their predictions. Ultimately, comprehending how intersection over union is calculated empowers you to deeply understand the performance of object detection models. It provides the quantitative foundation for refining model predictions, improving detection robustness, and ultimately leading to more precise and reliable artificial intelligence systems that can accurately perceive and interact with the visual world. It is a cornerstone concept for anyone working with or analyzing computer vision results.